Swift doesn't let you do this. It says no dice. You try to create this protocol and it'll say, hey, an associated type named T must be declared in the protocol or in a protocol it inherits. Now, most developers, we try to write code like this and run into this problem. Today, I'm going to show you how to fix this, and more than that, why it exists like this, and you'll have a clear understanding of the difference between associated types and generics. Let's get started. So what's the real issue here? The issue is the difference between generics and associated types. You see, associated types go into protocols because protocols define a promise, a contract between the implementer and people who want to consume it. It says, hey, I'm implementing this, I'm going to provide this information. And as such, it needs to provide the type as well. The implementer is providing the type. Whereas a generic, like in this case with this generic syntax here, a generic says, hey, the caller gets to decide the type. That's the fundamental difference. Generics are for the callers to implement, and associated types are for the implementers to choose. My take is they're both a variable. It's just who gets to decide what that variable ends up being, the caller or the implementer. If you're finding this useful or interesting, take a moment to like and subscribe. It really helps the channel. This is the 5th video that I've done on protocols, and you can see this playlist up here that contains the rest of them if you'd like to pursue more. The completed playground for this video is linked in the description. There you can find all that we've covered here, all that I've shown you, and play around with it for yourself. Let's look at an example. We've got largest here, and it is a function that is generic, and the type has to conform to comparable. So when we look at this, it just goes through and it finds the largest one and returns it. It doesn't care about the things that come in as long as it's comparable. So then we take it here and we look at it, and we pass in an array of these largest numbers, and it's going to print out the biggest one. And we can look down here, boom, 7.1. There you go, 7.1, perfect. And who gets to choose that? The caller, this guy. When we call it, he says, hey, I'm going to pass in and tell you what type I want it to be. Here's another generic. This is a struct this time that is generic over something that is numeric. Now, if we pass in, here we go, we call reading and we construct it. Here we pass in the label and then a value, this number. Now, this is a double. This is an int. This is the caller deciding what value to pass in and what type this will be. This is reading with a string and a double. This is reading with a string and an int. Again, the caller gets to decide. Now let's look at associated types. Here is a protocol instrument, and we have an associated type reading, and what that can do, it takes a reading, and it has a name, and that's all we define on this protocol. Now this is perfect because when we want to implement an instrument, when we want to create one, we want to be able to decide when we create it and have the instrument decide what kind of reading it does. For example, a telescope. A telescope is going to take a reading in something called the light spectrum, right? It's going to measure light. And then you could also do a seismograph. And the seismographs are for earthquakes. And so it's going to take a ground wave reading. And each one of these is determined by the implementer of the protocol. So telescope gets to decide, not the people who call telescope, but telescope itself. The implementer gets to decide the type. So what does that allow us to do? It means that each instrument produces its own specific type of reading, its own type. That's the important thing, is that a telescope is returning a type of wavelength. Seismograph is doing something completely different. And finally, a particle detector, completely separate. You can see that down here. You go and print it off, and we have, hey, we have a Hubble telescope, and it has a wavelength is what it's doing. We have the U.S. Geological Survey, and it's producing its magnitude stuff. Finally, we have Atlas at CERN, and it's got particle mass, and that's what it's measuring. So each one can make its own type and define it when it implements the protocol. The implementer chooses the type. The humdinger is right here. The caller here, when we call this, it is not choosing the type. The type was chosen up here by the implementer. Not here at the call site, but up here at the implementation, really in the definition of these structs. Okay, let's look at this side by side. Here we got a sensor, and it's generic over T, where T can be anything, right? Here we have an instrument, and it takes an associated type reading, and it has a thing that returns that reading. The only difference in this is they both have variables. They're both saying, hey, I have a variable, but who gets to decide what it is? In this case, in the sensor, it is T is a placeholder that is filled by the caller every time it wants to be used. On the protocol side, it's only done once, and that is when it is chosen. Let's look at an example for the generics first. Here we have sensor, and here it's choosing the light spectrum at the call site. Here we have another sensor, and it is choosing ground wave at the call site. And then when we print it off, we get to see these cool things down here. And here we go. Our two sensors, and our generic sensor comes from T, and then we have these two different ones, both made at the call site. But once we define it on a protocol, it has to be done on the implementation. And it chooses it here. So no matter how many times we call it, radio telescope is never going to change or vary. It's always going to return a light spectrum. You see that down here. It is returning a light spectrum. The cool thing is that we can actually combine these. So let's say we go back to our instrument, and it is got an associated type of reading. And we've got these two different types, our telescope and our seismograph and our particle detector, and that's cool. But now we're going to say we want to log an observation. And so to do that, we're going to make it generic over any instrument. So then when we call it, we are just going to let the caller decide what type of instrument it's going to use to log that information. And those types have already chosen their associated type. So we're going in multiple levels. Looking at this in action, here we go. We're going to say, hey, we're going to log an observation. This is generic over instrument. And we're going to choose a telescope. And it's going to print off its wavelength and its Hubble logging. And then we're going to go, hey, we want to log one from a seismograph. And it's going to do its stuff. Again, this is the caller being generic over something that is generic over its type, its associated type. And then finally, a particle, we're going to log another observation there. 3 different log calls, each chosen a different type, but these types chose their own subtypes for the return type. It's a lot of types. It's cool because the compiler has to think through that whole chain. It has to go, okay, now this is generic over this type, and that's going to be generic over this type, and it walks it through, and in the end, we have a concrete type, and it knows exactly what is being returned at these call sites. And it's what I love about Swift, type safety. The compiler can figure all this out. We can allow it to be whatever, but once we compile, the compiler can go through and figure it all out and say, all right, I understand exactly what you're getting, and that is a beautiful, safe thing. So now that you've mastered associated types and generics and protocols, what are you going to do with it? I'd like to hear about it in the comments.